Okay, so today is the first class, so we won't do a lot of things. We'll just study a few examples. And most of the examples are essentially 10 plus 2 example, 10 plus 2 plus maybe. And maybe some of you are also familiar with it. This is just to brush up our knowledge from 10 plus 2. Yeah, so essentially I will show you a few examples, the kind of problems that you see in combinatorics. Okay, so let me straight away write. This is all these things will be formally covered also later. So let me write this PHP. So this is the pigeonhole principle. I'm sure all of you heard it and at least know in some way or others in your 10 plus 2. So this is a statement. So there are n balls and k identical. Combinatorics could be really fun if you practice, and if you do not practice, then it could be really difficult. N greater than k, n balls and k boxes. We want to put the balls in boxes. Then this is obvious, right? There will be at least one box that contain at least 2 balls. This is an obvious statement that we all encounter sometime. Okay, so this is a popular name called pigeonhole principle. So it's best if we discuss a few examples to illustrate these ideas. So let me take an examples. So let's take an example. Okay, so consider so this course will be full of examples as it is discrete math. So my goal is to tell you some example, how to solve it and how to illustrate it in a brief manner so that other can understand your argument and solution. And then you can write it in your own language. So consider this sequence of numbers and so on. So the ith member of the sequence has I sevens, right? So show that at least one of them is divisible by, let's say, 2003. I mean, these numbers you can manufacture in many ways. It's just an illustrative example. So look at the problems. So this is purely a number theoretic question, right? You have a sequence of numbers 7, 77, 777, 7777, and so on. And you want to prove that there exists some number that's divisible by 2003. Okay. Okay, so since I listed it as an example inside pigeonhole principle, the first thing that comes to mind is that, okay, so I have to then play somehow around the remainders, right? When I divide and I get different remainders by 2003, I want to play around them and prove that certain element, certain number in the sequence leaves remainder 0 when you divide by 2003. Okay, so how do you prove such statement? It's not difficult if you know the right attacking route. So let us consider first 2003 elements of the sequence. Okay. So if none of them is divisible by 2003, then the set of possible reminders let's call it R. This is between 1 to 2002, right? Right? But you have taken 2003 elements in the sequence and you have choice only 2002 for remainders. That means there are exactly at least 2 elements in the first 2003 subsequence which will produce same remainder when you divide by the number 2003, right? That means, sorry, stop me if there is any question. That implies there are at least 2 numbers in that set so I call them 77777 is I times and 77777 j times, such that without loss of generality assume I greater than j, such that let's give it a name, let's call it AI and let's call it AJ, right? Such that AI and AJ leaves you same remainder when you divide by AI and AJ give same remainder and divide by 2003. That means AI minus AJ is divisible by 2003. I hope all of you know this mod notation from your 10 plus 2. So what is the meaning of this notation? This if means A modulo C mod some B means A minus C is divisible by B, right? I guess you know this notation. If you don't know, just stop me. But what is AI minus AJ? AI minus AJ is very simple. So this is 777 and rest are 0. So these are like J zeros and I minus J 777. Right? So what is that number? So this number is basically 10 power J times AI minus J. Right? But notice that 10 and 2003, these are relatively prime. So which that means what? AI minus J is divisible by 2003. That's it. Is it clear?
Yes, sir.
Yeah, good. So beauty of this PHP lies really in the example. There is nothing, I mean, stunning in the statement. It is fairly obvious statement, but it has a wide range of application, from graph theory, from number theory, from algebra, combinatorics. It is everywhere. Okay, so let me give you another example. Some examples are simple, some examples could be really hard. You have to think a lot to fit it into the framework of pigeonhole principle. Okay. So let's take another example. I have just collected a few examples from different books. So it's in a chess tournament, and there are n players, and each play with each other. So there is a tournament, a chess tournament, or any badminton tournament, and there are n players. They intend to play with each other, and the tournament is going on. One after another match is going on, and what you have to prove that at any point of time of the tournament, there exist at least two players who has played same number of games. Let me write it formally. Then at any time of the tournament, there are at least two players who has played same number of games. This is really fun, this kind of problems. So let's see. So if there exists one player, let's say player one, who has played with everybody. So there are player two, player three, player n. If there is one player who has played with everybody, that I joined by some line. In this case, all the players have played at least one game, right? Because two played with one, three played with one, so all of them played at least one game. But there are n players. N players, and the possible number of games played, nobody played 0 games because there is a player one who has played with everybody, right? So possible number of games played is 1 to n minus 1. So there are n players, and everybody played one of the numbers of game between the set 1 to up to n minus 1. Is there any chat? No. So that means it clearly shows that there, in this situation, there exists two players who has played same number of games, right? Again, by the pigeonhole principle. By PHP, there exist at least two players who has played same number of games. And if this case is not true, suppose there does not exist one player who played with all the n minus 1. So can someone quickly say what shall I do for that?
So the number of games played could be between 0 and n-2.
Right, exactly. Good. So this then you just repeat the same argument, right? Good.
Yes.
The other case, this is simple. This yeah, but this example should not mean that everything in PHP will be simple. Today is the first class, and we just started with some toy examples. Good. And so let's take some more examples. 1, 2, 3. So there are 10 points. 10 points are given within a box. This is a square box of unit length side. That means each side of the box is, let's say, 1 centimeter. Then we'll draw a picture also. Then there are at least. So see, the first one was from numbers, and the second examples are from some kind of real life situation, right? The third examples are also you can think of like from geometry. So there are at least two points closer to each other, than distance. Point. Since I don't write a unit, so you could think about like centimeter or anything. Yeah, so what is the problem? So you have a box, square box, and each side is 1. And you have to put 10 points in it. So the question that it is asking you to solve, no matter how you put this point into the boxes, so there will be at least 2 points. Their distance is less than 0.48. Okay. Right. So this is the problem of slightly different taste. Right? This is like a geometry, and some you are talking about distance, and you have to can you connect it to PGN? Okay. So okay, so this is one way to attack this problem. So let's take the box. And divide it. So there are 9 small boxes with side length 1. With this picture, can someone solve the problem?
Yes, sir. Like any 10 points will belong to same in 2 boxes, and the maximum distance between the boxes is less than 0.40. Is yes.
Right. So what he said is absolutely. See, once you know the right way to look at the problem, it could be really interesting. If you miss that right way, then you could land up in difficulty in arguing. Like you could start doing case analysis and trapped into wrong things. And how do you develop these intuitions? There is no other way. You can only develop these intuitions by solving problems. Just like you used to do calculus in your 10+2, the same thumb rule applies here. You have to try problems from various books, various sources, and master these ideas. That's all. Nobody has any other trick to solve this problem. So as he said, so if you place the 10 balls, 10 points in these boxes, then there will be at least one box that will contain 2 points. Then there exists at least one box of, today I'm writing it more, but not every class I'll write this. 1/3, 1/3, 1/3, 1/3, that contains at least 2 points. Right? But what is the farthest distance in that box?
The length of the diagonal?
Right. Farthest distance, as Siddhant said, is the length of the diagonal. So what is the length of the diagonal? That is like 1/9 plus 1/9, which is √2/3. That's like 1.414/3. That something it comes, which is roughly like 0.47 something, which is less than 1. This is right. So this way you can manufacture like many problems in PHP. So take another question in the same thing. You can also ask another questions. So prove that in the same setting, like you have a 1 unit box and you have to place 10 points in it. Prove that there will exist 3 points which can be covered by a disk of radius, that's the point. It's the same thing. You have this 1 unit box and you are putting 10 points inside it. And the question is that there exist at least 3 points which can be covered by a disk of radius 0.5. Can someone attack it?
Sir, could you repeat the question, please?
So question is the same. You have that box of 1 unit, square box, 1 unit length, and you have to place 10 points inside it, right? And the question is, prove that there exists 3 points in the box which you can convert by a disk of radius 0.5.
So you can just place 4 discs inside.
Sorry?
Like you can
I cannot-
divide the unit square into 4 parts and put a disk at the center of each square, and this will cover the entire square. So by PHP, some disk will
Right.
have at least 3 points.
So who is speaking? Rohan, right? So
Yes,
what
sir.
Rohan is suggesting, that just make it like 4 parts.
I meant 4 squares, but this might also this
Also work. Yeah.
yeah.
And Yes, so if you place 2, then you get 8. So there will be at least one slice or one triangle that will contain 3 of them, right? List one triangle contain 3 points. And then it's very simple, right? You have to just draw a circumcircle of the triangle that will cover these points. That's your solution, right, Rohan?
Yes, sir. But like if you divide it into two squares, the bound is much stronger than 0.5.
Yeah, I don't care here. I just wanted to.
Yes.
Then just take circumcircle. Cover. Good. Okay, so all these things are nice. Some examples on PHP. So I think you have not probably, it is not expected that you have seen graph theory, but maybe some of you implicitly have learned graph theory already. Someone is saying something. Ajay?
Sir, I have a doubt in the last question.
Yes.
So when you draw the circumcircle, it will go outside the box, right?
Yes. So, but it is just saying that you have to just cover it by a disk of radius point.
Okay. So, but it can go outside.
Yes. Yes.
But I thought it should be inside.
No. No. So as I started saying, like some of you must have heard this topic called graph theory. Maybe you have not studied it. You are not expected to study because if any of you have done already algorithms here, BSc first year have not done algorithm. Maybe MSc students, I don't know that they have done algorithm. So if you have done algorithm, then you have already seen graph theory, bit of graph theory. If you have not done, still I think somewhere you have seen graphs. Right? Graphs are very simple objects. You have like some vertices and there will be edges connecting vertices and their graphs are everywhere, like in internet, social choice theory, daily life is an example of a graph. You will see a lot of applications of graph theory in this course. Okay, so the next example that I'm going to show you, you can think of it's like a graph theoretic example if you want. But it's again from a real life situation. It's a famous example. Maybe many of you have already seen it sometime. I'll just repeat it. So there are 6 people. This is a famous example. Put that either 3 of them mutually known to each other, or 3 of them mutually unknown to each other. The problem is clear? The
Yes,
problem is,
sir.
I think some of you probably have seen it in some other course or maybe an Olympiad camp if you have trained there. So it's an illustrative example, which is quite nice. So let's see, how do you address? So we have to prove that either there exists 3 people where any pair know each other, they are friends, or there exists 3 people, like any 3 choose 2 pair, they do not know each other. That's what we are supposed to do. Okay, so how do you model this question? So let's take the one person, and this is the other persons, 2, 3, 4, 5, 6. I just named them. So since there are 5 of them, so definitely it is true that at least, not at least, so that means either 3 persons from the group 2, 3, 4, 5, 6 are known to 1, or 3 persons from the same group unknown to 1. Okay, it has to be right. I mean, the at least. Okay, so let's try to use this information. So suppose the first case is true. 3 persons from the group, they are known to 1. So maybe I just mark them 2, 3, 4. So they are friend of that person 1. So what I do, to indicate that they are friend, I just connect them. I put an H, put an H, put an H. So the age means 1 knows 2, 1 knows 3, and 1 knows 4, right? With this hint, can apart from Aditi, Rohan, and Vijay, can someone else say that? How do I attack this problem?
Sir, if any,
Siddhant, no, you also gave a solution. So Siddhant also not there. Yeah. So apart from this 4, yeah. Sorry, Siddhant. No, I'm just trying to distribute it to everybody. Yeah.
So can I answer?
Yes, yes, sure.
So in this case, if any of 2, 3, or 4
Right,
know each other,
right.
let's say 2 and 3 know each other, then 1, 2, and 3 will make a triplet.
Very
And
good.
if neither of them know each other, they will form a group who are not friends.
Very good.
Don't
So
mutually know each other.
right. So let's first write what who is saying true, right?
Yes, sir.
Let's just write as you correctly said. If any of the pairs in discrete math, always remember that you no need to write like a pages after pages. You have to write it very precisely so that person who is sitting in the other end can understand that you are writing a correct proof. It is not like writing a proof for an algebra. You have to be intuitive, but you have to be also, you will be providing some minimal information that the checker, that person can understand that you have understood the problem. If any of the pairs, as I said, 2, 3, 3, 4, and 2, 4 know each other, then we are done. Why we are done? Because suppose 2, 3 knows each other, then 1, 2, 3, they form that required set that we are looking for. Otherwise, 2, 3, 4 mutually unknown. To each other. Then also we have 2, 3, 4 is the solution. We are done. Right? Okay, good. So other case is really symmetric, but for the illustration, I would like someone else to try that. So let's say, let me draw the picture once again. So sorry. 1, 2, 3, 4, 5. So let's say now only 2 and 3 are known to 1. So 6. And other 3 are not known to 1. So can someone, this is symmetric argument almost. Can someone tell what will happen in this case?
So,
Yes, Romit, yes.
so either all of them know each other, in which case we have like the remaining 4, 5, 6.
Right.
Either all of them know each other, or one of them doesn't know like one of the others, in which case those two pair with one to make another
Right,
one.
right, very good. So good, Ramya. So either 4, 5, 6 know each other. In that case, 4, 5, 6 is the solution, and we are done. Else, as Romit said, there are at least one pair which is missing an edge between them, maybe the pair 4, 5. Otherwise, without loss of generality, 4, 5 do not know each other. In that case, 1, 4, 5 is the required solution, and we are good. Nice. Okay, so we continue on examples. Another tricks that happens always in combinatorics, and not just combinatorics, like in the most of the branches of mathematics, is the proof by induction. I think most of you know, you have done it in 10+2. Maybe already you have done in other courses also. The method of induction. Maybe I should remark, like, okay, discrete math as itself at this stage will not need lot of theory. It is mostly problem solving, but discrete math has its own beauty. Like if you study complexity or algorithm or many other branches of mathematics in future, many places you will see at the end you will end up a problem in discrete. You do a lot of heavy machinery, and finally you bring your problem to some problem in discrete math. So it is important to be reasonably good at discrete math, so that you can even attack problems in group theory or number theory or probability theory, ergodic theory, theoretical computer science. Many problems finally lands up in a problem purely in discrete math. As you go on in CMI, you will see. Okay, good. So I think the method of induction needs not much introduction. So this is like usually what we do. We want to prove some statement for all natural numbers, right? That is what we intend to prove from our 10+2. Let's call it n. And what is the steps? So there is a base case, there is an inductive hypothesis, and there is a induction step. So these are very, it's a very powerful thing. There are many theorems where we do not have a non-inductive proof really, or finding a non-inductive proof could be extremely tedious. But if you set up an inductive argument in a right way, it can largely simplify your life. And interestingly, all of us know it already. So the usual base case starts as problem specifies, so n equal to 0 or 1. This is the usual base case. And then the induction step, there is the inductive hypothesis, and induction step proves it for n+1 from the truth for, right? This is the usual thing. So lots of basic examples. I will not prove it because you definitely know it. So for example, you can prove 1 square plus 2 square x square n into n plus 1 n plus 1 by 6. I think in your 10 plus 2 probably you have proved it using induction. Right? Simple principle. You just prove it for n, and then to prove it I just write one line. Prove it for n plus 1, you just add n plus 1 square, then you group and substitute by this value and add n plus 1 square with it, and convince yourself that it is simply n into n plus 2, 2n plus 3 by 6. Okay, so this is really very basic, but there could be more interesting example also. So let's take a slightly more interesting example. Right. So, okay, so there are, let's say there are n lines on the plane. It's again an example. This was example from numbers. This is an example from geometry. Such that no two are parallel and no three are concurrent. Then the number of regions they form is equal to n into n plus 1 by 2 plus 1. Let's assume n is equal to 2. This is the problem, right? For example, if you put just, I hope the problem statement is clear. So if you put just one line, it divides the plane into two parts, right? One part and two. Put two lines, one part, two part, three part, four. Plug 2 here, you can exactly see the value is 2. And you have to prove this fact for general n. Okay, how do you do it? Think about it. Check that for n equal to 2, this let's call this value as fn equal to 4. Think about it in a simple geometric manner. How do you so n lines you have already drawn, and they have subdivided that plane into lots of regions. By inductive hypothesis, this is n into n plus 1 by 2 plus 1 regions. And all you want to argue is that if you put an additional line, then this number
The additional line will actually intersect with the previous n lines to produce new n regions.
Right. Exactly. So exactly what he said. So just let's illustrate what he said. So there are 3, and maybe there are 3 lines already you have. Okay. Good. Who said it? Who said?
So it was Nilabjo.
Nilabjo. Because by that I will know all of you also. Good, Nilabjo. So these are the 3, suppose 3. Now I put a new line. So as Nilabjo says, can you just make the argument concrete?
Sir, actually each intersection produces a new region.
Good.
I mean, the new line, I mean, this fourth line will intersect with the previous three lines in three different points.
But how? But one thing, Neelaj, you have to be. You are right, but little bit more careful. Like how many region it intersect. That we have to understand, right?
So it will actually produce n, I mean, what, 4 regions and
Exactly.
extra being produced, n plus 1.
Right. Good, very good. So there are 4 regions that it intersect, and every region it pleats and produces one more, right? That's your argument, right, Neelaj?
Yes, sir. Yes.
Good, very good. So so now what is the relation between Fn and Fn plus 1?
So Fn plus n plus 1 is equal to Fn plus 1.
Say it again, sorry. Fn plus 1 equal to?
F of n plus n plus 1.
Very good. So this, if you have not followed the argument, just work it out offline. It's not difficult, and you don't need to need big theory for it. So now just let's put the values. There was 1, so I just write it n plus 1, and then 1 I shift. So this is exactly equal to n plus 1, n plus 2 by 2 plus 1. Okay, so good. Okay, so let's take maybe one more example. This is not exactly an induction example. I'm mixing lots of examples, so I find it interesting. So let H be a 10-element set of 2-digit positive integers. Then H has 2 disjoint set A and B such that the numbers that belong to, so all of you are familiar with this sum notation. You have done algebra already, right?
Yes, sir.
Right. This is shorthand. That's the problem. So H is a set of 10-element set of 2-digit integers. Then I have to prove that H has at least 2 disjoint set A and B such that their sum of the numbers that the contents are same. Is the problem is clear? If anybody is not sure about the problem, just feel free to ask.
So A and B are any disjoint subsets, right?
Yes, you have to argue that there exist at least 2 disjoint subset A and B of that big set H, such that the elements, if you add up inside the set A and inside the set B, they are exactly same.
Oh, okay, sir.
Good. Try.
So the maximum sum of any given 10 less than equal to 10 size set is less than 1000, and there are 1024 possibilities. So two
Good.
sets will have the same sum.
Rohan,
But
you have a solution. Yeah, I got it. You have a solution. Good. So can anybody else other than Rohan say that? Good, Rohan. Good. So but apart from Rohan, can anybody else say it?
Continuing on what Rohan said,
Right.
we can obtain 2 subsets, not necessarily disjoint,
Okay.
which have the same sum by Pigeonhole by PHP, and we can then remove the common things, I mean common
Exactly.
numbers between them
Yes.
to make them disjoint.
Right. Good. So I just summarize. Okay. So proof. Number of subsets of H is 2 power 10 minus 1, which is what? 1023. And the different sums possible. So this is like, what is the maximum sum? I just write little bit formally so that everybody see. So what is the maximum number of sum possible? I'm just I'm lazy and putting a loose bound, right? 996. Yes. Because the maximum number would be 99 and I just multiply it with 10. It could be even better than that, but I don't care for it. So that then there exists. Was that your argument, Ayan?
Yes.
Yes. There exist two set A and B such that is same. Now, as Ayan said and Rohan said, remove common elements from A and B to get A prime and B prime such that A prime intersect B prime is empty and summation A belong to A prime A is equal to summation B belong to B prime. This is what. Okay. So today we just did a few examples, right? We did not do any theory as such. Okay, I think I will stop today. This is the first class, and see you on.
Sir,
Yes.
could you explain the question again? I think I understood wrong because
The last question. The last
yes.
question is okay. So you have a set H that has 10 elements, and the elements are from 2-digit positive integers. Okay.
Yes.
Then you have to prove that you can construct two disjoint sets from the big set H. Let's call them A and B, such that when you add the numbers inside set A and add the numbers inside set B, they are exactly the same.
Okay, so we don't need to break it into two parts, right? We can just take some elements. We can have elements left over, if I'm not wrong.
Yes, they are not like any subset you have to take.
Okay.
The question asks you to construct any subset.
Okay.
Is that even true that what he said that if A union B equal to H, then will this be satisfied with the additional constraint? That is the statement true then?
Say it again. A union B.
All the conditions are the same. Plus A union B should be H.
Okay. Not sure. Perhaps not. I don't know. Perhaps not.
Or a weaker statement, that is, does there exist an H such that this is satisfied? That is A union B and all these conditions on A and B. Does that
you can check it offline here.
Okay.
Okay, so someone is writing in the chat.
We can take 5 odd numbers and 5 even numbers.
So what questions you are attacking? Rohan, Sankar? So I think that was probably false. What he first wanted to ask.
Yes, sir. So anything like if the entire set sums to an odd number, or all numbers are odd
Right.
and the sum is divisible by 4.
And there was some other question that he asked. I didn't remember. Some other question someone asked. Yeah, this is clearly false. The first one. The second one, I don't remember what he asked. Okay, so I think I'll stop recording.